So we're going to spend some time graphing systems of inequalities in this section. And just to kind of get us started out here, I've got 4 different inequalities that you can graph. Now there's a link on D2L for this. You can jump on that and it should take you to something kind of like this right here. Now the first thing you're going to need to do when you graph an inequality is graph the corresponding equation. So the corresponding equation for this one is 3x plus 4y equals 12. Personally, I would suggest you graph this by just figuring out a couple points. Set x equal to 0, get y equals 3. Set y equals 0, get x equals 4. So let's plot some points like that. 0, 3 is up here. 0, 4 is here. Now the kind of line that you're going to use is going to depend on whether or not you have a less than or equal to, a greater than or equal to, a less than or a greater than. So for less than or equal to or greater than or equal to, you're going to use a solid line. If you have a less than or greater than, you're going to use a dashed line. So it makes a difference as the style of inequality that you're going to use, or a style of line that you're going to draw. I'm going to assume that maybe the first one is going to have a less than or equal to, so I'll draw a solid line here. Now the thing that distinguishes this from just a regular old linear equation is you've got a less than or equal to sign. What that means is that on one side of the line or the other, all the points are going to satisfy this inequality. So, okay, what's that mean? Well, what we're going to do to try and figure out what side of the line satisfies the inequality is we're going to use a test point. So that test point has to be a number that's off the line. So let's see. This would be a good test point because it's right here. It's not on the line. And you're going to plug that into your inequality and see if it makes it true or false. So I'll test 0, 0, and 3x plus 4y is less than or equal to 12. And let's see what happens. 3 times 0 plus 4 times 0, is that less than or equal to 12? Well, what do you think? Yeah. You end up with 0 is less than or equal to 12. And that's true. Because it's true, not only that point, but every single point on this side of the line is going to satisfy the inequality. So that's the region that I want to shade. I want to shade everything over here. And so that would be my final solution.
How do you shade?
You shade the true side. Now, if you're skeptical, like, well, I don't know. I don't know if that one's true. What if we test a point up here? Let's say 5 and 5 or 4 and 5. I'll do 5 and 5, even though this doesn't quite look like 5 and 5. 5 and 5, say. Now, this is on the opposite side of the line, and I've already shaded down here. These should test out true, so any point up here should test out false. So let's see what happens if I tested that point there for you. So if I test 5 and 5, that's going to be 3 times 5 plus 4 times 5. Is that less than or equal to 12? Severa, is that true or false? Is 35 less than or equal to 12?
No.
That's false. So the good news is that you only have to test one point. If it tests out true, you're going to shade everything on that side of your line. If it tests out false, you shade on the opposite side of your line. So you only have to test one point. One point's going to tell you what's going on for everything. Now, the difference is, are you working with a less than or equal to, or just a less than? Are you working with a greater than or equal to, or a greater than? And let me just kind of flash through all the different possibilities there with you. So with a less than or equal to, you're going to use a solid line. And we just did that one, we shaded below. If I had just a less than, then the difference would be I'd have a dashed line. Okay. How about if I have a greater than or equal to? Well, in this case, you're going to end up shading above the line. So there's everything above the line. What's going to be different when I click this last one where I have just a greater than? It's going to be a dashed line. And that's it. So what I'm trying to review for you here is just kind of quickly looking at what happens when you have a less than or equal to versus a less than, or greater than or equal to versus a greater than. But either way, you're going to shade just one side of the line or the other. Now, in keeping with the work we're doing in this section, we're going to work with systems of nonlinear inequalities. That sounds like a mouthful, but what you're really looking for is the points that satisfy both inequalities at the same time. So let's take a look at the first one here. And if you wanted to jump on the Desmos link, you can. That's this one here. And let's shut these off. Go all the way back up to the top. So here's your two equations. Hopefully you're comfortable graphing these. You know, just plug in points like I did with the first one, set x equal to 0, set y equal to 0, and get your intercepts. So 0, 10, and then 20 and 0. And then our other one doesn't have nice integer solutions, that's okay. There's your points. But now I want to test some points in shade. Now, the problem gives you the point, I think 2 and 9. Yeah, 2 and 9 as a test point. And you can test that in your inequalities by just plugging it in. So the answer's here, and some of this got cut off, I think, a little bit. So this point is a solution to the system of equalities in x and y by substitute x equal 2 and substitute y equals 9. And if it satisfies both of these, then it's a solution to the system of inequalities. So must satisfy both to be a solution. And by satisfy, I mean make true. And in this case, it does. If you were to plug in, say, x equal 2 and y equals 9, actually I can't use 2 and 9, I think. I think that's going to be actually a point right on our graph. Now, let me just look back at this here. Yeah, 2 and 9 is actually on one of these graphs, so let me use 1 and 9. That's not on our graphs. So if you substitute in that into both equations, it'll tell you where to shade. In the first one you shade below, and in the second one you shade below. Our solution to this system of inequalities is not going to be this big mess here. It's going to be where these things overlap. So that's going to be your solution, is where they overlap. And that's what we're looking for here. Now in that first inequality, first thing here, all you're looking for is x equal 2 and y equals 9. But let's make it look a little bit more like what you're going to face at home for your homework, which is something like this. So shade the system of inequalities for the given graph. So I've already put in the graph of some of these for you, but that's just for the convenience of your notes. When you do these for yourselves, you're going to have to come up with a graph for yourself. All right, so we've got these two. I'll squeeze the first one in here. Second one I'll go to another sheet of paper for. You're going to start out by graphing the equation that corresponds to this. So what corresponds to this is x minus y equals 0, or x equals y. And from there you can come up with the graph, x equals y. All right. So what's the graph of that going to look like? Well, you can plot points to get the graph. You can set x equal to 0 and then y would equal 0. You can set x equal 2 and then y would equal 2. Or you could realize that this is in slope-intercept form. What's the slope of this line?
1.
1. What's the y-intercept? What's the y-intercept? 0. So if the y-intercept is 0, it has to be this line right here. So let's do that. Shade it that way. Then obviously this has to be our other graph. Now you can get points for this one by just substituting in. So over here I've got x plus y equals 3. Just make yourself a little table, set x equal to 0, and then set y equal to 0. If I set x equal to 0, what happens for y?
It's 3.
3. If I set y equals 0, x equals 3. So, all right, I get a couple points. And then I've got my graphs. But we're not done. We have to decide what side of the line each of these things get shaded on. So in this first one, I need a test point other than 0, 0. I could use 0, 0 to test this line, but I can't use it to test this line. So I'm going to pick the point 0, 2. So that's 0 and 2. And that's going to be my test point for both inequalities. So let's see, we'll test 0, 2 in this inequality. X minus y is greater than or equal to 0. So 0 minus 2 is greater than or equal to 0. Is that true or false?
False.
Yeah, negative 2 greater than or equal to 0? I don't think so. So that's false. If that tests out false, what side of the line is it telling me to shade on? Above or below? Shade above? Ryan, you're shaking your head no.
If greater than is false, you would go below.
Yeah, if this tests out false, you want to shade the other side of the line, so you have to shade below. You want to shade the side that tests out true, that one tested out false. But tell you what, since you're a little bit nervous about that, let's pick another point. Let's pick a point, say 2 and 0. 2 for x, 0 for y. That'd be 2 minus 0 is 2, and 2 is greater than 0. So we want to shade below. So that's everything below, right here.
Oh, you plugged it into the first one.
Yeah, we got to plug it into the first one, because that's the one we're testing right now, is the first one.
Okay.
Now, how about the second one? Let's test 0, 0, or test 0, 2 in that one. Test 0, 2. And this time we're going to test it in the second inequality. So it's going to be x plus y is greater than or equal to 3. Is 0 plus 2 greater than or equal to 3?
Yes. Oh.
Oh for 2. Man, rough day. 2 is not greater than 3, so that's false. All right, last chance of redemption here. If this tested out false, do I want to shade below and to the left or above and to the right?
Above to the right.
Above to the right. Redemption is yours. All right, good deal. So that's above and to the right. Please don't leave it like this. On the test, if I'm on my game, I'll put down, make your final answer clear. Your final answer is the region where these things overlap. So one way to do that is just to circle this and say, all right, that's my solution right there. The place where they overlap, that's my solution. Now I'll show you a different way to kind of express your solution in the next problem. But basically what you're looking for is where those shaded regions overlap. You can double check yourself on Desmos if you like, but while I'm here for the moment, are we okay with what we just did here? All right, a little nod from Hannah, thank you. Dalen, good with that? So let's shut this one off and look at these. Oops, see, I gotta get rid of the solution here still. That's that one. Okay, so these two overlap right here, which is the region that we shaded. Perfect, perfect. Okay, let's look at example C. Example C is very similar to the previous example. Can anyone tell me the difference between example C and example B?
First one's less than.
Yeah, the first one's less than, second one, first one here is a greater than, first one here is a less than. So I've switched the signs here, but the graph is gonna be pretty much the same. So let me do things this way. We already know that that's gonna be x equals y. That's gonna be that graph right there. And we know the other one, x plus y equals 3. So we're okay with that one. But I am going to do something a little bit different here in terms of the rest of the problem. And that is, when I do my work with testing points, I'm going to make that a little bit different, or at least the shading part a little bit different. So I can stick with the same test point, 0 and 2. And let's test 0, 2 in the first inequality. And that one should test out the same. Actually, it should test out a little different because we changed the inequality. Is x minus y is less than or equal to 0. So 0 minus 2 is less than or equal to 0. Think carefully for a second. I know. Ryan, true or false?
I'm pretty sure it's less than 0.
Negative 2 is less than or equal to 0, so that's true. Cool. So where am I going to shade? Below or above? Above. So this point is our test point. I want to shade above. So I'm just going to put a couple little arrows like that to remind me that I'm going to shade above. And let's move on to the next one. Let's test 0, 2 in our next inequality, which was this one. X plus y is greater than or equal to 3. So that's 0 plus 2 greater than or equal to 3. Oz, true or false? False. Am I going to shade above to the right or below to the left?
Over to the right.
Above and to the right, good. So let's just do that here, just write a couple little arrows. now that I figured out where I'm gonna shade, your job, I'll give you a minute, especially if you're watching this at home later, is to just fill in where these shaded regions overlap. That is, instead of just drawing everything and then circling where they overlap, just give me the region where they overlap. So just give me the shaded part. All right. So where is it they're gonna overlap?
The part where the arrows are pointing towards each other.
Right up here at the top. So when you're graphing these things and giving me the solutions, you could either do something like this so that I know, all right, that's the solution because that's where they overlap, or you could draw everything and then circle it. But one way or another, I want you to convince me that you understand that your solution is where these things overlap. You can see that if we look at it on Desmos, here and then here, those shaded regions overlap in that kind of martini glass profile that we see up at the top. So, beautiful. Let's slow things down a little bit and do a couple on the easier side. Y is less than negative 7x. So I include these because, you know, it's easy to forget what some of these smaller graphs are, simpler graphs. We're going to start by graphing y equals negative 7x. And for that, you might just want to do yourself a little t-table here. Plug in some easy points. So let's do that. Plug in a couple easy points and get our graph. Annie, give me a couple points here for x, some easy ones. 0, 1, and 2. Perfect. All right, 0, 1, and 2 would give me 0, negative 7, and negative 14. So let's put those points on our graph. 0, 0, 1, negative 7, and 2, negative 14. Okay, looking good there. As far as the line is concerned, what kind of a line should I use to draw this? Yeah, thank you. A dotted line. So, dotted line here, along there. Now, my favorite test point is 0, 0. Can I use 0, 0 as a test point for this graph? No. So, what test point do you want to use?
1, 1.
All right, 1, 1. That's going to be up here someplace. You know, hard to, let me zoom in on the scale here a little bit. So, 1, 1 is going to be, you know, up here someplace. Doesn't really matter exactly where, just as long as we have it someplace. So test 1, 1. Now I'm going to test that in the inequality that we have up here.
Less than negative 7.
Y is less than negative 7x. 1 is less than negative 7 times 1. True or false?
False.
True, false. No, that's what you're supposed to decide. All right. All right, so that one's false. All right, so giggles. Which side am I going to shade? Above and to the right or below and to the left? Below to the left. Well done. So below to the left. All right. Let's move on to this one. Try and go a little faster on a couple of these. Y is greater than or equal to 4. We're going to start out by graphing y equals 4. So, all right, if y equals 4, that's great. What's the graph of y equals 4 going to look like? Yeah, it has a slope of 0 and a y-intercept of 4. So it has to be a horizontal line through 4. And you could break out a test point. 0, 0 works for a test point, but let's just think about it. where you're gonna find values of y that are greater than or equal to 4. Above the line or below the line? Above the line, yeah. So if I put this one on their exam, you know I must have been having a good day. All right. Make sure I'm having a good day when I write the exam. Will do. All right. This last one, I'm going to make that x is less than or equal to -2. Otherwise, the graph doesn't fit too well on our paper. And try and graph that one. See what that one's going to look like. Okay. What's the line x equals -2 going to look like? Yeah, a vertical line. So x equals -2 is going to be a vertical line. Solid line because we've got a less than or equal to. So solid line here. Which way am I going to shade? To the left or to the right? Yeah, you want numbers that are smaller. Smaller numbers are going to be to the left. So, wow. Cool.
That was easy.
Yes, nice. All right. Let's flip it over. You've got two inequalities here. These are your nonlinear inequalities. They're not nice and straight like the last three were, but we can still work with them. The first one you should have as a solid circle. Now this is a circle. Personally, what you could do here to try and find some information about the circle is first of all figure out where the center is. And as far as figuring out where the center is, what value of x makes the squared term equal to 0? Well, 0, right? So x equals 0 is the x coordinate of the center. How about the y coordinate of the center? What value of x or what value of y makes the y term equal to 0? 2. So there's your center. Now as far as the radius is concerned, and I guess we're looking at both of these because we have to consider the equation x squared plus y minus 2 squared equals 4. The right-hand side is going to be the square of the radius. So if I want the radius, I got to take its square root. So there you go. If you were stuck coming up with this graph on your own, what I would do is I would start out with the center, which is at 0, negative, or 0 and 2, and then do all 4 points of the compass. North, south, east, and west. So, 0, 4, 0, 0, 2, 2, -2, and 2. So those would be your different points. This is your center, 0, 2. So looking good there. But ultimately, when you have these inequalities, you have to decide where you're going to shade. So it comes down to testing of some points. Now, can I use 0, 0 as a test point? 0, 0 is my favorite. I want to use 0, 0. Now, Nick's correct. I can't use 0, 0 because the equation would actually pass through there, nor can I use 0, 4. Can I use the center? Can I use 0, 2? Yeah. Sure. So we'll test 0, 2. So you get 0 squared plus 2 minus 2 squared equal, or is less than or equal to 4. Is it less than or equal? Yeah, less than or equal to 4. And let's see what happens. 0, and 2. Well, is 0 less than or equal to 4?
Yes.
Yeah, that's true. So where am I going to shade this circle? Inside the circle or outside the circle?
Inside.
Inside. So let's make it look like a kind of a demonic eyeball. I'm going to shade inside like that. There you go. There you go. But yeah, you do get shaded inside. And so much for our demonic eyeball. But it's shaded inside is the correct region to shade. Your next one, a little bit different because it's got a different center. The center now in this case is 0, 0. What's the radius?
3.
Square root of 9 is 3. Good. So center is at 0, 0. Radius is the square root of 9, which equals 3. So if you were to actually zoom in on this graph, you'd see that it's graphed by moving 3 to the right, 3 to the left, up 3, and down 3. What test point do you want to use for this one? 0, 0. Sure, why not? Test 0, 0. Is 0 squared plus 0 squared greater than 9? That's false.
So it's outside?
Yep. So since 0, 0 was our test point and it tested out false, you want to shade everything outside. So, hey, cool. Kind of like an eclipse. Coming up in just a couple weeks. Say again?
What day is it on again?
Monday, April 8th.
So 2 weeks.
Yeah, 2 weeks.
What is? Wait,
The eclipse.
oh, the eclipse.
Yeah, the eclipse. All right. 2 more. Now, don't expect the equations already graphed for you. I do that because it's tough to keep up with the notes if you're trying to draw these graphs at the same time. So here's negative x squared plus y equals 3. No shocker that it's a parabola. You could rearrange things and write it as y equals x squared plus 3. So it's just shifted up 3 from the point 0, 0. But let's see. I need a test point. What am I going to use for a test point?
0.
0, 0 would work out fine. 1 and 0 would work out fine. I suppose since,
The 0 is greater than 3.
so you can see that on my graph, I can do 0 and 20, whatever points you want to choose. So 0, 0 works out fine for a test point. 0, 0. So negative of 0 squared plus 0, is that greater than or equal to 3? False. So where do I have to shade? Inside the parabola. Yay. So shade inside the parabola, and we've got one last one here. Now there is one thing I want to point out about this graph, and it's really the answer to this part right here. Why is this drawn just in the first quadrant? I want you to think for a second about x is greater than or equal to 0 and y is greater than or equal to 0. What are those graphs going to look like? Well, let's see here. Let's do both of those. X is greater than or equal to 0 is going to be the right half of your coordinate system. Y is greater than or equal to 0. Anyone want to tell me what that's going to look like before I graph it? It's going to be on top. And where do they overlap? They overlap in the first quadrant. So that's all I've drawn for my graph right here is the first quadrant. So, let's see, 9. Let's shut these off, go all the way down to the bottom. So, let's see. I think most of you caught it when I said it earlier. This needs to be a positive 1/2 right here. Now, as far as these equations are concerned, their graphs are things you can come up with pretty easily. Since this has a negative slope, it has to be this graph right here. And I'm only drawing it in the first quadrant because of these two constraints. These are the kind of constraints you get when you solve linear programming problems for like industry. They're called natural constraints. You have things like manpower has to be number of hours greater than or equal to 0, or number of people greater than or equal to 0, that kind of thing. This has to be my other graph. And now you're going to play that game of testing points. I'll test 0, 0 in here, and y is less than or equal to negative 2x plus 6. So here's my test point. 0 is less than or equal to negative 2 times 0 plus 6. That's true. 0 is less than 6. Where does that mean I'm going to shade? Down to the left or above to the right? Here and here. Let's try our other one. Can I use 0, 0 again? Yeah. Yeah, 0, 0 is not on that line, so we're okay to use that one again. So is 0 less than or equal to 1/2 of 0 plus 3? 0 less than or equal to 3? Yeah, that's true. So where am I going to shade now? Below. And let's take a look at what happens when we do all that shading. So here's our first one, here's our second one, and if we shut those off, our solution looks like that. It's just that little bitty shaded region, kind of close to 0, 0 in the first quadrant. So here's our solution. Right here. And that does it. That does it for this one. I went over that last one a little bit fast. If there's some questions about it, please let me know. If not, then see you.